All right, still in section 5.3, I'm now going to show us another way to divide a polynomial by a binomial. It's called synthetic division. It's a much more convenient, much more compact way of dividing instead of using long polynomial division. First, I'm going to divide this trinomial by this binomial using our long polynomial division that we've seen in the past. Then I'll show you the quicker way called synthetic division. All right, so let's do long polynomial division first. No placeholders necessary here. Here we go, round number one. X divides in x squared how many times? X times. X gets multiplied by our divisor. X times x is x squared. X times 2 is 2x. Subtract off the whole polynomial. The x squareds drop out. Negative 5x subtract 2x is negative 7x. Bring down to plus 6. Round 2 of division. How many times is x divided into negative 7x? Reduce, negative 7 times. Take negative 7, multiply it by the divisor. Negative 7 times x, negative 7x. Negative 7 times 2, minus 14. Subtract off the whole polynomial. The negative 7x's drop out. 6 subtract the negative 14 is 6 plus 14, or 20. You have nothing else to bring down, so this is called our remainder. Go up to your quotient, put a plus sign, and place the remainder 20 over your divisor. Ladies and gentlemen, you got your answer. This is your quotient. Now, another way to divide a polynomial in general by a binomial is to use what is called synthetic division. Now, synthetic division requires that your divisor always be of the form of x minus c. And then the idea behind this is you divide this number c into the coefficients of the dividend. So in synthetic division, you're not going to see any variables. You're just going to see numbers. So let's do this problem over again, but this time, let's divide this trinomial by this binomial using synthetic division. Notice my binomial divisor is of the form of x plus 2, which to fit it to this form is really x minus a negative 2. So I'm going to divide a negative 2 into the coefficients of my dividend. And the coefficients of my dividend are 1, negative 5, and 6. Synthetic division is very easy to do. Drop the 1 down. What we do is we multiply, bring the number up, and add. Negative 2 times 1 is negative 2. Now we add these together. Negative 5 plus a negative 2 is negative 7. Multiply, negative 2 times negative 7, bring the number up is 14. And now we add 6 plus 14 is 20. And we're done. It's that simple. So what happened is we took a second degree polynomial, we divided it by a first degree binomial. Therefore, the degree of our quotient is going to be of degree 2 minus 1, or is going to be a first degree quotient. Hence, my quotient is going to be 1x minus 7 plus my remainder 20 over my divisor, which is x plus 2. Ladies and gentlemen, we got the same answer that we got up here when we did this division by long polynomial division. This is called synthetic division. It's much more efficient, much more compact than going through long polynomial division. Now, this synthetic division only works for divisors that are of this type, though. Synthetic division will not work for division by a trinomial or a 4-term polynomial. It has to be a binomial. It has to look like this. Let's try another problem. by using synthetic division. Okay, so we're going to try another one here. I'm going to take x squared plus 8x minus 12, and I'm going to divide it by the binomial x minus 3. But this time we're going to use synthetic division, not long polynomial division. Notice my divisor is of the form of x minus c. So in this case, I'm going to divide 3 into the coefficients of my dividend. The coefficients being 1, 8, negative 12. Here we go. 3 times 1 is 3. Add. 8 plus 3 is 11. 3 times 11 is 33. Add. Add these together, you get 21. And we're done. This is your remainder. My quotient is going to be 1x plus 11 plus my remainder 21 over my divisor, which is x minus 3. And we're done. This is your quotient after having divided this trinomial by this binomial. Notice with synthetic division, if you have a plus here, you divide the negative in. So plus 2, we divided negative 2 in. Minus 3, we divided positive 3 in. So we always divide the opposite of what this sign is. If this is a plus, you divide the negative in. If this is a minus, you divide the positive in. Synthetic division. Let's try another one here. All right, let's try to divide x cubed minus 27 by x minus 3 using synthetic division. So I'm going to be dividing the positive 3 in to the coefficients of my dividend. Now notice my dividend is missing some powers of x. I have a third degree term, but I'm missing a second degree term of x and a first degree term of x. We need to insert placeholders. So the coefficient in front of my third degree term is 1. 0 is the coefficient in front of x squared. 0 is the coefficient in front of x to the first power. And then I have my constant term. Now we begin synthetic division. 3 times 1 is 3. Add, you get 3. 3 times 3 is 9. Add, you get 9. 3 times 9 is 27. Add, you get a remainder of 0. That's your remainder. Our quotient, therefore, is going to be, notice I took a third degree polynomial and divided it by a first degree polynomial. Therefore, the degree of my quotient is going to be of the degree 3 minus 1 or second degree. So my quotient is 1x squared plus 3x plus 9, and there's a 0 remainder. This is your answer. This is your quotient. So you gotta love synthetic division. It is so much more compact than long polynomial division. Let's try another one here. Let's try to divide x cubed plus 2x squared plus 3x plus 4 by x minus 2 using synthetic division. So I'm going to divide positive 2 synthetically into the coefficients of my dividend. Notice I'm not missing any powers of x in my dividend. I have a third degree term, second degree term, first degree term, 0 degree term. The coefficient in front of x cubed is 1. Coefficient of the second term is 2. Coefficient of the third term is 3. And my constant term is 4. Bring down to 1, and let's begin synthetic division. 2 times 1 is 2. Add 2 plus 2 is 4. Multiply 2 times 4 is 8. Add 3 plus 8 is 11. Multiply 2 times 11 is 22. Add, you get 26. Done. This is your remainder. So my quotient is going to be of degree 3 minus 1 or second degree. So 1x squared plus 4x plus 11 plus 26 is my remainder over my divisor. Done. This is your answer. This is your quotient. It's so much quicker than long polynomial division. It's called synthetic division. All right, let's try another one. Let's take this long polynomial here. 2x to the fifth minus 3x to the fourth plus x cubed minus x squared plus 2x plus 1. And we're going to divide this huge polynomial by x plus 2 using synthetic division. So I'm going to divide -2. Notice the opposite of this sign. So I'm going to divide -2 into the coefficients of my dividend. And notice I'm not missing any powers of x. 5th degree term, 4th degree term, 3rd degree term, 2nd degree term, 1st degree term, 0th degree term. So here's my coefficients. 2, -3, 1, -1, 2, and 1. We now begin synthetic division. -2 times 2 is -4. Add these numbers together, you get -7. Multiply, -2 times -7 is 14. Add, 1 plus 14 is 15. Multiply, -2 times 15 is -30. Add, you get -31. Multiply, -2 times -31 is 62. Add, you get 64. Multiply, -2 times 64 is -128. Add, you get -127. -127 is your remainder. I took a 5th degree polynomial and I divided it by a 1st degree binomial. Therefore, the degree of my quotient is going to be a 5 minus 1 degree or 4th degree. 2x to the 4th minus 7x cubed plus 15x squared minus 31x plus 64 plus -127 is my remainder over my divisor of x plus 2. Done. This is your quotient. Could you imagine how long? So ladies and gentlemen, when I'm done, this is my quotient. Imagine how long this would have taken had you performed long polynomial division. It would have taken a lot of time and a lot of space. Synthetic division is much more compact. Okay, so I will assign some problems that will have you divide polynomials by binomials using synthetic division.